Okay, this lesson we're going to be talking about trig functions of any angle. Trig functions of any angle. So not just acute angles, now we're going to be going to angles that are sometimes acute angles, but many times larger than 90 degrees. And the reason being is because we're going to now be talking about all four quadrants on our coordinate plane. So we're going to have quadrant 1 is in the upper right, quadrant 2 is in the upper left, and then we go counterclockwise 3 and 4. So quadrant 1, 2, 3, and 4. It's important for you to know which quadrant is which, and we name them with Roman numerals. Now an angle in standard position is going to have the initial side being the positive x-axis. So the positive x-axis, you might be saying, what's the positive x-axis? The positive x-axis, which is going to be the initial side, is this angle, or this side right here. The positive values, right? So positive 1, 2, 3, 4, 5 on the x-axis. That's your initial side. And we're going to have the terminal side is going to be in any, it can falls in any quadrant or on any axis. So there's your terminal side right there. Now I just had this terminal side fall into quadrant 2. So I'm going to put over here counterclockwise. You're going to do a counterclockwise turn, counterclockwise angle of rotation, and I'm going to mark that with CCW. That's one way to get to your terminal side from your initial side. And then you're going to also be able to turn clockwise from the initial side to your terminal side. So either one of those is going to work. However, we're going to have to tell the reader which way we're turning. Are we turning clockwise or counterclockwise? So this turn is a clockwise turn, because that's the way the clock turns. So that's CW, clockwise. I don't like the way I wrote that there. Clockwise. And that's a clockwise angle of rotation. Now this is important. So your clockwise represents negative angles. Here, let me just do this. Clockwise represents negative angles. So I wrote that in green. And then your clockwise turns, counterclockwise turns rather, counterclockwise, that's a positive angle. So if we start here at the positive x-axis, and I don't rotate any amount, that's 0 degrees. And if I rotate counterclockwise to the positive y-axis, that would be a 90-degree turn. If I rotate another quadrant to the negative x-axis, that would be a 180-degree turn. So here's 90 degrees, and then here's 180 degrees, and then each quadrant is 90 degrees. Okay, so each quadrant is 90 degrees. So if you go all the way around the entire circle, you would make it to 360. So 0 degrees and 360 degrees happen to be in the same location. Now, negative turns we would go the opposite way. So we would start at 0 degrees, and then a negative turn would be negative 90 degrees, and then turning a little bit more, exactly another 90-degree turn, would be at negative 180 degrees. And then if I turn 3/4 of the way, going clockwise, that would be negative 270 degrees. And then if we went all the way around the circle, that would be negative 360 degrees. Okay, so let's see what it is that we're going to do here. We are going to show you an example. So if I wanted to say, well, I've got this angle right here. It's got an initial side, positive x-axis, and then it has this terminal side in quadrant 2. Estimate the amount of the turn. So I would say that this was about 90 degrees. So this is how I would do this. I'd say this is about 90 degrees to this point. And then this part is about another 30 degrees. So in total, we'd have about 120 degrees. So that's where 120 comes from. Now in this example right here, now the arc is very important. So this arc is very important. It tells you that you're starting at the positive x-axis, and where the arrowhead ends, that's where your terminal side is. So this one I said, well, you know what? This one looks like it's about 20 degrees shy of being a 90-degree turn, and it's going clockwise. So clockwise is a negative angle. So that's negative. And then the amount of the turn, amount of rotation, is about 70 degrees. So we're going to say that that's negative 70 degrees. Very good. Okay. So now let's state where the terminal side lies for each one of these angles. 700 degrees. 700 degrees. 700 degrees is going to be, I have to draw a picture, it's going to be counterclockwise. And I'm going to start at the positive x-axis at 0 degrees, and I'm going to turn 360, but that's not going to be enough. So 360 twice is 720. So this is going to be 360 plus 340. So here's 360 degrees plus another 340 degrees. So 340 degrees is going to be just 20 degrees shy of going all the way around a second time. So that tells me that our angle is going to fall, that terminal side falls in quadrant 4. So here's our terminal side. I'm going to highlight the terminal side in blue. That's where the terminal side is. Now these arc marks are really important because they tell you, okay, that's 360 plus another 340, which makes your 700 degrees. So it's important that you have both parts of that arc, that turn, when you're drawing your picture. Okay, negative 320 degrees is just shy of negative 360, which is a full turn by 40 degrees. But this time that's a negative turn, so this is going to go clockwise. So we start at the positive x-axis, and we're going to turn clockwise. And I'm going to stop short of 360 degrees by about 40. So that's about this is about 40 degrees. This other turn is about 320 degrees. 320 plus 40 is 360. But because we're going clockwise, this is negative 320 degrees. Negative shows the direction. So that means this terminal side lies in quadrant 1. So the terminal side of the angle lies in quadrant 1. 175 degrees, 45 minutes. That's going to be a counterclockwise turn. And it's just shy of 180 degrees by about 4 degrees and 15 minutes. So that's almost going to be a half a turn. We always start on the positive x-axis, and then we're going to turn the amount of rotation going to our terminal side, and that tells us that our terminal side is in quadrant 2. Quadrant 2. And this turn, this arc, represents 175 degrees, 45 minutes. Okay, so when we come back, we're going to, before we do coterminal angles or talk about coterminal angles, we're going to just talk about maybe a quadrant, talk about a few things. I just want to make sure we've got it before we've got coterminal angles, but then we're going to go right into coterminal angles and complementary angles, supplementary angles, all sorts of good stuff.